Hey everyone, I'm sorry I couldn't be with you today. So today we're going to wrap up our discussion on how we describe variability around a distribution. So when last we left, we were talking about standard deviation. And standard deviation, again, which is S of X, is really always greater than or equal to 0. So you're going to see some value there. And then large values of the standard deviation mean that there's more variation in your data, that it's more spread out across your data. Standard deviation is not a resistant measure of variability. So if there are big outliers, that's going to change the standard deviation. And standard deviation is a variation around the mean. So what we're going to talk about today is what happens when we don't have a mean, but we instead have a median. So now let's talk about what we do with a median, which is we use quartiles and what's called an interquartile range, or an IQR. So that's interquartile range. Okay, so we know how to calculate the median. We remember this from last time, that we find the number that is directly in between. So we've looked at this data set before. We know that in this particular data set, the median is 50. So our first quartile is just halfway between our lowest point and our median. So if we look at the median, if you'll remember, we had 14 data points here. So halfway between that would be 7. So I'm going to go 1, 2, 3, 4, 5, 6, 7. Okay, and that's 7. I'm going to count here and make sure. 1, 2, 3, 4, 5, 6, 7. Yep, we're good. So the interquartile range, much like the median, if it's not an odd number and it's even, like in this case in 14, we're going to say that it's halfway between these two. So we're going to take the average. So quartile 1 is going to be 29 plus 32 divided by 2. So that's 61 over 2. Which is equal to 30.5. So our first quartile is 30.5. That means 25% of the data is going to fall here, and this is our quartile 1. Then we know another 25% of the data is going to be here, and it's going to go from quartile 1 to our median. Then we need to find our quartile 3. So again, same thing, 1, 2, 3, 4, 5, 6, 7. And 1, 2, 3, 4, 5, 6, 7. So this would be our quartile 3. So quartile 3 is going to be 75 plus 79 divided by 2, which is just a nice, easy 77 over 2, which is 38.5. Okay, so the interquartile range, to come up with our interquartile range, so again, the concept is there's 25% of the data between each of these values, right? And then this value is our max, and this value is our min. So the interquartile range is just your quartile 3 minus your quartile 1. So in this case, that would be 38.5 minus 30.5. So I get 8. So my IQR equals 8 in this case. A good way of thinking about the IQR is saying, look, the middle point of the data, 50% of the data that's in the middle is going to fall between this 38.5 and 30.5. And we remember that range is always a single value, so our IQR value is 8. So when we have a median, we can talk about things in terms of IQR when we're talking about variability. Okay, so we're going to talk about what IQR has to do with outliers now. So in terms of our AVISCO, we have talked about shape, center, and variability, but we have left out outliers. So I'm taking the example of letters of recommendations that teachers write because there are a lot of outliers in this direction. So we have 32 teachers that wrote letters of rec this year. So if I divide that by 2, that's 16. So I'm going to start counting. Let's see here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Okay, so this is going to be my median. And that's really easy because 3 plus 3 divided by 3 is 3. So I know my median right here is 3. I'm going to find my quartile 1 again. So I know that's 8. 1, 2, 3, 4, 5, 6, 7, 8. Again, easy peasy. 1 plus 1 divided by 2 is 1. So my quartile 1 has a value of 1. And I'm going to look at my quartile 3. 1, 2, 3, 4, 5, 6, 7, 8. So here's my quartile 3. So quartile 3 is going to be 5 plus 6 divided by 2, so that's 5.5. All right, so if I'm going to calculate my IQR, which I need to do, I'm going to say, okay, it's quartile 3 minus quartile 1, so that's 5.5 minus 1, which is 4.5. So what does that have to do with outliers? Well, we have these rules. Low outliers. If there are low outliers, they will always be less than your quartile 1 minus 1.5 times your IQR. And your high outliers will always be greater than quartile 3 plus 1.5 times IQR. So we've got this 1.5 times your IQR, which makes sense because if we're saying IQR is 50% of the data, if we see a value, 50% of the data is in here, and we see a value that is 1.5 times higher than that above the quartile 3, that seems like kind of an extreme. So let's check and see if this data has any outliers. So quartile 1 is, we know that that is a 1. So 1 minus 1.5. Okay, guess what? I'm going to stop there. I know that's a negative number. I don't even need to multiply my IQR to realize I don't have any negative values here. So there's no way that I have low outliers. So I'm just going to move on to my high outliers. Quartile 3 is 5.5 plus 1.5 times IQR, which we calculated as 4.5. Okay, so that's going to be 5.5 plus 6.75. And when I use my calculator, I get 12.25. So what does this mean? It means that high outliers, I should probably erase that there. High outliers are going to be greater than 12.25. So I'm going to look here and be like, oh, look, 12.25 doesn't exist, but all of these exist, which means there are 5 special teachers who are outliers. Okay, so this rule of the 1.5 times IQR, add that to the quartile 3, subtract that from the quartile 1, shows us where we have data that's really out there, data that is very distinct and different from the other data sets. And that's going to be important to talk about when we start talking about our distributions. Okay, so when I was showing you the test yesterday, I talked about a 5-number summary, which is a descriptive way that we talk about statistics. And the 5-number summary is just this. It's your lowest value, your quartile 1, your median, your quartile 3, and your highest value. So if I were to do a 5-number summary for this, I'd say my lowest value is 1. Right, my quartile 1 we determined from the other from the last slide was 1. Our median is 3. Our quartile 3 was 5.5, and our highest value is 34. So that would be our 5-number summary for this particular data. Well, now that you have a 5-number summary, what do you do with it? Most often a 5-number summary is used to create a visual display of the data with a box plot. So a box plot is a special type of numerical graph or data representation that we're going to talk about today. So a box plot, and I know this isn't going to make sense, so we're going to write down the words and then I will do it for you. We create a number line to cover our range of our data. So we make a number line to cover all the way from our min to our max. Then a central box, like a literal box, is drawn from quartile 1 to quartile 3. So we literally make a rectangular box. Then we put a line in the box that kind of cuts the box that marks the median. Then little lines called whiskers extend out to the lowest and highest points that are not outliers. So every time we do a box plot, we're going to have to calculate our IQR and our outliers with our IQR to come up with the end of where our whiskers are. Okay, and then we put little dots or little X's that are placed to mark where the outliers exist. Okay, so this is how we do a box plot. Okay, how would we box plot here? So the first thing that we're going to have to do is put these in numerical order. All right, so put these in numerical order. I kind of ran out of room there on the side, but there's 23 data points there. These are the letters of recommendation written by female teachers at Holy Names. All right, so the halfway point here, the median would be, since there's 23, take one away, that's 22, so 11. So I went 11 and then I circled the next value. So the median is 3. Okay, so here's my median. Again, my quartile 1 is going to be halfway between my lowest and that. So I should have 10. So I'm going to go 5 and then 1, 2, 3, 4, 5. So the middle one there, my quartile 1 is in fact 1. And then quartile 3, 1, 2, 3, 4, 5 is going to be this. Quartile 3 equals 7. Okay, and I don't know about the outliers. There might be some, so let's take a look at this and see. So again, to calculate my IQR, I'm going to say it's quartile 3 minus quartile 1. So that's 7 minus 1, which is 6. So to get my low outliers, quartile 1 minus 1.5 times my IQR. So in this case, that is 1 minus 1.5. I'm just going to stop right there and say that doesn't exist. Quartile 3 plus 1.5 IQR, that might exist. So my quartile 3 is 7 plus 1.5 times my IQR, which was 6. Okay, sum all that up, that's 16. So any value that is higher than 16 is going to be an outlier. Okay, so let's scale this. So I can put all my values up there and I can do this and I can see, okay, we have a quartile 1 of 1. So there's that box. Quartile 3 is 7. So I make this rectangular box here. And then my median is at 3. So notice I didn't split the box evenly, it's just where my median is. So this is going to be my quartile 1, my median, my quartile 3. Do I need to label that? No, but I just did that for you guys. Okay, then I need to find a value that is, so I want to know where my outliers are. So I'm going to put boxes around my outliers. Anything that's above 16 is an outlier. So 16, all of these 4 are outliers. And our highest value that isn't an outlier is the number 11. So we draw whiskers to our maximum value that is not an outlier. In that particular case, our maximum value that is not an outlier is 11. So I'm going to draw my little whisker there. And I'm going to mark all of my outliers, 18, 21, 24, and 34. Okay, so this is my box plot for the data looking at female teachers' letters of recommendation. And if you'll notice this side over here doesn't have any whiskers. The whiskers are supposed to represent 25% of the data. This represents 25% of the data. Normally this would represent 25% of the data, but because there are no whiskers, it's actually like 50%. And it's not exactly perfect, right? Because we have some outliers here, but it's just trying to show you that the data is smushed up here. So if I were to draw a distribution, though it doesn't quite give me the shape, it would look something like that. Okay, so the box plot gives us an idea of where the outliers are and sort of where most of the data lies. So here I ordered the numbers and I did some of the data analysis already for you. This is for the male teachers. So when I put it in order, I found that the median was 3, the quartile 1 was 1, quartile 3 was 4. I got my IQR to be 3, and I calculated that any high outliers are going to exist over 8.5. So Merlino, that's you. So we have, again, a box here. At 4, there's a box here, right? And then our median is right there at 3. No whiskers on this side either. And again, this is very unusually skewed data to not have a whisker on the other side. And then I'm going to my highest point, which is 4, which is literally right there. So there's no whiskers. And so then I would, in fact, list my one outlier here. So this is what the male teachers' data would look like on a box plot. So what I'm going to show you now is how our TI-89 can help us. So yesterday we talked about calculating the standard deviation, and that is really difficult by hand. So let's figure out how to do this. So we're going to go to apps and our Flash apps if you have words. Otherwise, we're going to arrow down to Stats List Editor. And I have my list of all the teachers who actually, this was not, what was this? Oh, this is fun data. This is the number of sites, number of times people visited Naviance. So we might as well use this data. So let's say I want to calculate the standard deviation, or I want to calculate the mean or something like that. So what I'm going to do is this button up here where it says F4 calculate, that would be right here. So I'm going to press F4 calculate, and there's something that says 1 bar stats. I'm going to enter that, and I need to tell it what list I want to do. Now I put mine in list 1. I could sit here and go alpha 4, alpha 9, alpha 3, T1. Or, again, I could take the shortcut and say second minus find my list 1 and just hit enter. Okay, so I'm basically saying, look, I would like all these statistics for list 1, please. And I hit enter and look, I wait patiently and look at this beauty. I've got my X bar here, so here's my sample mean. I've got S of X, that's my standard deviation. I've got my sample size, my min, my quartile. See the tiny little thing that says Q1X? There's my quartile 1. If I arrow down, that's my median, my quartile 3, and my max. So I have all of these values here, which is super helpful to find great information. So let's do that same thing on the 84. So I'm going to go to Stat right here. And if I want to edit my list, I can hit enter and I can see, oh, look, there's my list that I entered in last time of all the number of times that people visited Naviance. All right, well, I'm going to go back to Stat, press it again, and I'm going to arrow over to calculate this time. And look, there it is, 1 bar stats, same as it was in the TI-89. I can tell it which list I want. Again, the lists are here, second, and then over this key. So I already have list 1, so I'm good. But if I wanted a different list, I could do so. I, however, want list 1. That was a lot of lists, so let's clear that. Boom. And try that again. List 1. And then I'm just going to arrow down and hit calculate. And again, I get all of the same values. I have my min, my quartile 1, my median, my quartile 3, and my max. Okay, so now we can ask ourselves, great, we know how to do 1 var stats. That's wonderful, but can we also make our calculator graph? Why, yes, we can. So again, I'm going to go to stats list editor if I have an 89, and I'm going to press this second and then apps, and that should take me back to where I was before. And for me, that's always stats list editor. So here I have my list of data. I'm going to go back to plots where we were before, and I'm going to go to plot setup. Now I have a histogram from before. That's great. I don't want it, so I'm going to press F3 clear. Boom. And now I'm going to define this. So I see scatter over here. I'm going to arrow over and hit instead modified box plot. The difference between a box plot and a modified box plot is the modified box plot shows outliers. So this is key in my mind. Then it's going to say, what do you want your X to be? Again, I'm going to take that shortcut, second minus, and I'm going to find list. Okay, so I should see all of this little dots and it says list 1. So now I've put it in here. I'm going to hit zoom data and I should get, boom, a box plot with my whiskers and my outliers. Okay, and if I want to, I can hit F3 trace and I can see what my median is, my quartile 3, my highest value that wasn't an outlier. My outliers, 153, and we're not shocked that 210 visits to Naviance is an outlier. Okay, so this is a great tool for figuring out how to do this. I will give you a warning. If you are in calc, this graph is offensive to calculus. So if you're trying to graph something in calc and you can't, you want to go back to your plots and be like, wait a second, do I have any weird plots in stats that are holding me up? Yes, you likely do. And you can access it this way, or you can go to y equals, and you should be able to see this crazy plot might be offending you in calculus. So please remember, if you're in calc as well as stats, some of the stats graphs make calculus graphing difficult, so you want to clear them when you're done. Same game, only with the 84. So this time with the 84, we're going to stats plot, right? Because we're making a statistical plot. So second y equals. Again, I'm going to go here and arrow over. We had something from before. So I'm going to go over here and I'm going to give the type. We might have had a histogram before. So I'm going to choose this one with the box plot with the little dots. That's a modified box plot. I want it to be list 1 and blue looks great. It's fine with me. I hit enter and then I need to tell it that I want to see it. So I want to zoom in on it, and I'm always going to zoom stat, which is number 9. So zoom stat, and then there I go. There's my whiskers, there's my outliers, same as with the 89. We can trace as well, just like we did with the 89. The last thing you really need to be aware of with box plots is this idea that the box plots do not always show gaps, clusters, or peaks. If I were to look at this box plot, I would think, oh, the data kind of looks like this, but clearly this data does not. We have 2 peaks right here. So it's important to know that box plot isn't always the best for gaps, clusters, and peaks. The histogram will be better for that. Okay, so just kind of summing up everything we've done. This was looking at the female letters of recommendation and male letters of recommendation with the box plots. We drew the box plots each individually on a page, but I wanted to show you it is very possible that we could put them on top of each other to do some sort of a comparison. right? So this is a good way to look at data, is to put the box plots side by side. And again, here's a box plot versus a histogram versus a dot plot. Right, so looking at these are just different ways to represent the data. Okay, so at this point you should be, we're done with the chapter, and I want to give you the rest of the time for you to work in your on your bias project with your groups. Have a great day.